Introduction to Trigonometric Ratios. In our previous work in class, we've looked at the properties of similar triangles, and we've also looked at the properties of the ratio of sides in similar triangles, and we're going to develop that into what's called trigonometry, or the study of triangles. We often say trig for short, so trigonometric or trigonometry is often just abbreviated to trig. The three ratios, or the three ways we can compare the sides, are here. We've got one called sine, S-I-N-E. It's abbreviated as S-I-N. That is not sin. Sine, cosine, which is abbreviated as COS or cos, and tangent, the tangent ratio, abbreviated to TAN, tan. Sine ratio is defined as the opposite over the hypotenuse. So in other words, the length of the opposite side over the length of the hypotenuse. Remember, these are for right-angled triangles. You must have a right-angled triangle. Cosine is adjacent over hypotenuse, so it's the length of the adjacent side over the length of the hypotenuse. Lastly, tan, or the tangent ratio. Tan of an angle is opposite over adjacent, or the length of the opposite side over the length of the adjacent side. How this works on a triangle is that rule number one, very important, you always start at the given angle. If this is our given angle, you can see the little symbol theta. Theta is the most commonly used symbol in maths to mean angle, theta. We can see that if we go from theta across the triangle to the opposite side, we get that O there. That O stands for opposite. So the opposite over the adjacent would be the tan of that angle. If we compared starting from the angle, the opposite and the hypotenuse, we would have the sine of that angle using the sine ratio. It's written over here on the left. Again, starting at the angle, if we compared the adjacent side to the hypotenuse, the length of the adjacent side divided by the length of the hypotenuse, we would have the cosine of that angle, or cos theta, we say. Now, there's lots of ways of remembering those three, sine, cos and tan. You will need to remember them too, very important. Trigonometry is one of the most important topics in school maths. It has an enormous number of applications and is used all over the world many times. So some people look at sine, S for sine, and O for opposite, and H for hypotenuse, and put all that together as SOH. Then they get C for cos, A for adjacent, and H for hypotenuse. And they put the C, A and the H together. They get the T for tan, O for opposite, and A for adjacent, and put those three letters together. And some people put it all together as one big sound, and that's called SOHCAHTOA. SOHCAHTOA. So that can help you if you can split them up. And remember, sine is opposite over hypotenuse, etc. Some people make a mnemonic over it, which is using each letter as the start of a word. Like, some old hippies can't always hide their old age. So that's another way you can use, I don't mind what you use, but use something to help you remember it until you've learnt it for good. You will have just noticed me using the side names of the side lengths of a triangle. Now there's a certain skill and we need to know how to label the sides and also use definitions. So there are three. There's O, A and H, opposite, adjacent and hypotenuse. Remember, always start at the given angle. So how do we get O? O is opposite. So perhaps if you consider this triangle here as some strange looking swimming pool and you're resting in the corner with your elbows on the side of the pool just looking out at the pool, you might think, I'm going to swim to the opposite side of the pool. And that would be over here. So you swim straight across, and that makes that the opposite compared to the angle. OPP for opposite. The other side that is well known is, if you see this right angle here, if you go opposite the right angle, that's called the hypotenuse, and you'll find that that's something that you already know from your work in Pythagoras. Hypotenuse is the longest side, and it is also opposite the right angle. Lastly, to get A, adjacent, we start at the given angle and we look at what's next to it. The next to it side is the adjacent. Adjacent is a word that means next to. You might think, well, hold on there, there's another one next to the angle, there's this one. Well, that one's already taken, it's got a name, it's called the hypotenuse. So that only leaves this one here called the adjacent. So it's important to be able to label the sides of a right angle triangle. Remember, you start at the given angle. Lastly, some examples. This is an important skill you will need. We need to write a trig ratio in fraction form, so we don't have to calculate the decimal, for each of the following triangles. So we're going to have to choose out of sine, cos and tan, and we're going to need to put them in the correct order. The correct thing over the correct thing. They can't be upside down. First one, start at the given angle. What do we have? We have an adjacent and we have a hypotenuse. So CAH, katoa, or can't always hide, cos is adjacent. Cos is adjacent over hypotenuse. I'm just writing A over H. So to get cos theta, we go adjacent over hypotenuse, and in this particular case it's 5 over 7. In the second question, the given angle is here. What have we got involved in this question? We've got a 4 and a 9 there. The 4 is opposite and the 9 is the hypotenuse. Opposite and hypotenuse, that's some old hippies or saw. So opposite over hypotenuse, which in this case is 4 over 9. The last one, we have the given angle here, opposite and an adjacent. So that's their old age, opposite over adjacent, or tawa. Tan theta is opposite over adjacent, which is 3 over 5, and that's our trig ratio. Obviously these are just numbers, but we're working towards the stage after we've mastered this skill where we can actually use trigonometry to find the lengths of sides of triangles where we can't use Pythagoras' theorem. We can also use it to find angles, and therefore there are many real life problems we can solve using trigonometry.